In today's video, let's talk about a special parameter on op-amps called the gain bandwidth product. The gain bandwidth product is a steady parameter that gives the user information about gain and frequency response for a particular op-amp. Let's take a look at the Bode plot so you can see this visually. On the y-axis we have a gain scale in decibels, while on the x-axis we have gradually increasing frequencies on a logarithmic scale. The key idea here is that as you increase your frequency, the amount of gain that the op-amp can provide begins to decrease. The gain bandwidth product provides a number that encodes this information for the user. In an open loop configuration, the gain of the op-amp is provided on the spec sheet and is labeled AOL. For an open loop op-amp circuit, the gain bandwidth product is just the open loop gain of the op-amp multiplied by the cutoff frequency, or -3 dB below the top flat line. For our op-amp in this example, the open loop gain, which is a unitless quantity, is 1 million, while the gain bandwidth product is 10 MHz. We can see that our gain begins to drop off at 10 Hz. Our open loop times our cutoff frequency of 10 Hz is just our gain bandwidth product at 10 MHz. This means that we can reliably expect a gain of 1 million from the 0 to 10 Hz frequency range, but once we start dealing with frequencies higher than 10 Hz, our gain will begin to decrease at a rate of 20 decibels per decade. Notice that the gain bandwidth product is consistent no matter where you're at on the Bode plot. If our gain bandwidth product is 10 MHz, then we should expect 1 million gain at 10 Hz. This means at 100 Hz, we should expect a gain of 100,000. This is because the gain bandwidth product continues to just be the frequency, in this case 100 Hz, times the gain at that frequency, in this case 100,000. You can see that as our gain drops to the 20 decibel level, our frequency is placed at exactly 1 MHz. If we convert 20 decibels to our linear gain, we get 10. This once again aligns with our gain bandwidth product of 10 MHz because we have a gain of 10 times 1 MHz. The gain bandwidth product for a typical op-amp is usually measured by identifying the frequency at which the open loop gain drops to unity, or a gain of 1. This plot here shows that we hit 0 decibels, or a linear gain of 1, at exactly 10 MHz. This is where we get our gain bandwidth product of 10 MHz. So how does this work for an op-amp in a closed loop configuration? Let's build a simple non-inverting amplifier. Let's say the gain bandwidth product on the spec sheet for this op-amp is 1 MHz. The gain of this non-inverting amplifier is 100, so we assume this op-amp begins to notably attenuate at 10 kHz. If we run this simulation at 1 kHz, we can see that our voltage and time plot shows an unattenuated sinusoid able to achieve its desired gain of 100, which gives us 1 volt peak amplitude. If we bump our frequency up to 10 kHz, our output is now slightly attenuated and unable to reach that full 1 volt peak amplitude. Why is this? If we take a look at the gain to frequency Bode plot, we can see that our gain, originally at 40 decibels or a linear gain of 100, is now sitting at 37 decibels with our frequency of 10 kHz. 37 decibels is equal to a linear gain of 70.7. This is why our voltage and time plot gives us a peak amplitude of about 700 millivolts, because the gain is decreased -3 decibels right at 10 kHz. That is the gain bandwidth product. As a quick note, where I see people get the most confused is at the frequency corner. Understand that on this Bode plot of a particular op-amp, we can expect a steady gain value for most of the frequencies leading up to the cutoff frequency. However, your gain right at the cutoff frequency will be -3 decibels below your open loop gain, or the gain you've selected for your op-amp configuration in a closed feedback loop. We can use the gain bandwidth product to ensure signal integrity and decreased attenuation of our amplified signal. If you're working with high frequency circuits, it is likely that you need an op-amp with a really high gain bandwidth product, or you will need a multiple stage amplifier to guarantee the gain and signal integrity needed.